9, 8, 7. Okay, we are live. Hello everyone, welcome back to week 5 of Intro2Astro 2022. Thank you so much for joining us today. The topics today are how to create a CV and a professional website. And we will also talk about ongoing James Webb Space Telescope. Finally, we'll hear from Sam about his life story as a young astronomer. Meanwhile, if you have any questions, feel free to post them on the YouTube channel as well as on piazza.com. All right, let's move on to the first topic today, creating a CV. And our first speaker is Jack.
Hi, everyone. All right, so we're going to talk about CVs, what they are, what they aren't, and how to make one for yourself, and what to keep track of and think about when you're preparing a CV. So the first thing is that CV. The letter CV stand for curriculum vitae, which is Latin for like your life's work in some sense, which sounds very daunting. But it that kind of is what it's supposed to be. It's supposed to be a single document where someone can look at it and say, oh, you've done all these things, and then they can go all the way down and get a good picture of what your academic and professional career has been like up to this point. And so your CV should definitely be a living document. You should be looking to update your CV often. And that in itself is a bit of an exercise. Just remembering to update it and keeping it up to date is, can be a chore sometimes, but it is important. So coming up with a strategy of consistently updating your CV is in itself very important. But let's talk a bit more about the details. So your CV, again, is this big summary of your life's work and your accomplishments. And the idea is that it's usually used for things like if you're submitting for a job, if you're applying for a job, or if you're applying for grant proposals, or anything where you are trying to put yourself out there to receive some kind of, again, job or grant money, anything that you're trying to bring into yourself or put yourself out there, that's what your CV is used for. So, when you apply to graduate school, often they'll ask for a CV as part of your application to the school. And so that's why it's important to have one even as early as your undergrad career, because very quickly people are going to start asking for your CV, and so it's good to have something ready. It may not be perfect in the undergrad phase, and it's certainly not complete because it's supposed to be your life's work, and if you're only an undergrad, then your life's work is nowhere near done. But it's important to have something to put together and to give a summary of who you are and what you've done. CVs are very similar to, but definitely different from, resumes. A resume is supposed to be a single page. It's supposed to be a very, very condensed version of who you are and what you've done. That single page limit is very strictly enforced for a resume. Whereas for a CV, there is no page limit. And in fact, some CVs are very long. And that's okay. They're supposed to be. If someone wanted a very, very short document, they would ask for your resume. But often in academia, they ask for your CV, because in academia, there's a bit of a broader kind of spectrum of work that we do in academia. And so it can't really be properly captured in a single page resume. But so resumes and CVs, they're very related, very similar, but distinct. And so you could think of it that all resumes are CVs, but not all CVs are resumes in some sense. And while it is also kind of important to have a resume kind of in your back pocket, in academia, people don't ask for your resume as much, so it's not something you have to update as much, or to have on hand as easily as, say, having your CV, which you should always be ready to kind of send as an email to someone. But okay, so now we've kind of defined what a resume, or sorry, what a CV is, or the uses for it. Let's talk a bit about what goes in a CV. There's no like single correct way or to put items on your CV or to format your CV. There are certainly items that are very often included on people's CVs, and conversely, there are items that people exclude from their CVs. But there's no like one way to do this. And I think maybe an example I can pull up mine as an example of what some common categories are. I think mine is well, maybe I'm biased. I made it, but I think it's a fairly average in terms of what I put on it, kind of CV. So one thing that's very important is at the top, you want to include your name and you want to include all your contact info, just like you would on a resume. So I put my email address. I do have a website, put an office number and my Twitter handle, as well as my mailing address at the school that I'm at. This is pretty standard because, again, if you are applying for a job or you're looking for a grant or a fellowship that you applied for, you want them to be able to contact you to tell you that you've been given the job or awarded the grant money. So this is very standard to have your contact info at the top. Next, it's very common to include a section on your education, just a brief overview of where you have attended and the degrees that you've earned. And so this is my section here. Then it's very, very common to include this section, which we call appointments. And appointments are kind of a fancy academic world lingo for jobs. These are the jobs that I've held. But in academia, they like to call them appointments for whatever reason. You could just as easily put jobs up here, and no one would bat an eye. But so this is a very brief summary of the jobs that I've worked in the past, and of course the times that I've worked in the rough years. Now, it's important though that when you're including the jobs that you've performed, on your CV, particularly if this is an academic CV and you're applying for academic jobs or academic fellowships, it's important to only include the jobs that you've done that are relevant to your research, your academic professional life. So for example, I've also worked at a golf course. I did that for a couple summers in high school and in college, early college, but that's not something that I would include on my CV because it's not relevant to my work in astronomy. The exception is that, or it's okay to include jobs that are not necessarily within the academia world, but only if they're relevant to your research in academia. So for example, I did work as a data engineer for a private company for a couple of years, and I was doing a lot of software development. And so that is relevant to my research, and so that's why I've included it in my CV. Next, a very common section to include on CVs is your teaching experience, if you have any. Now, this is something that certainly very few undergrads have, because just undergrads are not teaching. Very few undergrads are TAs. I do know of some that have been TAs, and it's very different for every school around in the country and around the world. But if you do have teaching experience, whether that's formally like in a classroom, as part of the college, or if you've been a tutor of a certain class, this is an area that you could put information about that. And again, this is just something that maybe gets filled in a little later in your career as you just do this more. But it's important to remember, as you do begin to teach, it's important to keep track of those classes and the times that you taught them, because you will want to put them into your CV. Next, it's very common to have a section which goes by many names, but I've called it honors, awards, and fellowships. This is just a list of the ways that I've been recognized in various fashions. And it's kind of a place that you can brag about yourself a little bit. It's okay to promote yourself and be proud of the accomplishments that you've earned. And so a lot of people will have this section as well. Next, I've included this community service and outreach section. I really like this section. Not everyone has one, but I think it's important because I think as part of being in science and academia, I think Also giving back to the community and teaching, in a public outreach setting. I think these are important things. And so I try to do these things a lot. And so for that reason, I wanted to include it on my resume. And so, for example, I've included my mentor position here in the summer course. And I've just given a brief description of what the course is so that someone who would be reading this resume would know just kind of a simple 2-sentence answer of what this course is. And so another thing, though, is just like with appointments or jobs, it's wonderful to be doing community service and outreach outside of your academia professional life. For example, maybe volunteering at a local soup kitchen or cleaning up the local river. Those are wonderful things, but they're not really relevant to an academic CV. These should be community service outreach that are relevant to kind of the field that you're in. Another thing that some people will include, and I have, is a list of presentations. So I've been lucky to go to a couple conferences and give a couple talks. And so I've just listed them here. That's something, again, that as you progress through academia and through your undergrad and perhaps grad student and beyond, as you move through this part of your life, you'll accumulate presentations, or you will have given many presentations. And so this is just a place that you can kind of compile all those. I included this one. This section is actually brand new for me because I only just completed this course, professional development. I did a workshop on learning how to be a better software engineer, and so I included that as like a kind of a way to show that I'm trying to work on myself, both as a astronomer, but also as a person, and learning more skills. So this is something you could put on as well. And then lastly, or not lastly, but I do have a section on some press coverage that my research has gotten. A couple popular science articles have been written about a paper that I wrote. So I wanted to compile them here, but this is not necessarily even common maybe in a resume. But so these are the general kind of sections of a resume. But again, there's no formula to this. You can include some of these sections. You can exclude other sections. However it works for your life, your career. Because again, it really is your CV, and so it should be tailored to your life. And that is to say that, again, maybe at this stage in your life, you're high school right now, or you're in the early stages of your undergrad career. Maybe again, you haven't given a presentation at a conference, and that's totally expected. And so you wouldn't have that section yet, but then when that day comes where you do give a presentation, then you can create that section and update your resume. The thing about resumes is that they really highlight kind of the good things that you've done, the accomplishments that you've made in your career. And so that's always changing as you're growing and learning and becoming a better scientist just through the act of practicing science. Your resume your CV will grow with time. It is that living document. And so that's why it is important to be updating, maybe every couple months, or if you do go give a presentation, you that day maybe update your resume before you forget, or sorry, your CV. I keep saying resume, but update your CV, that night after you give the presentation before you forget. Real quick, I'll show you an easy way of how to get your own resume started. I think it was last week we learned about Overleaf and LaTeX. So I've logged into my Overleaf account. If I just hit New Project, and then I scroll down here to Resume or CV, there's a bunch of templates here that you can choose from. These people have very kindly put together these templates, and you can kind of get a sense for what they look like from these preview pages. There's like a ton of pages on the site of these templates, but let's just click on one. For example, so then you say open as a template, and now all of a sudden I'll have a new Overleaf project, which will have all this code pre-written into it. And some of them will have some kind of notes to you saying these are custom commands, I guess, but let's scroll a little further down. It says CV starts here. So now it says, here's where you should be inputting your name and your phone number or email, whatever you want to put in here. Feel free to delete things if you don't want your phone number, just delete it, no problem. Here's a section where your heading is, and they've very nicely filled in an example. So you put in the name of your institution here, and then the degree that you've earned, as well as the dates, and perhaps you put your GPA. If you don't want to do that, just delete it, and so forth. So these templates are designed to kind of get you started, and then you kind of fill in the rest there. So this is an easy way to kind of get your feet wet with a template, with a CV. Let's see. Another thing I wanted to say was, let's see. Oh yes. So I've said that you do want to be updating it, and so something that I personally do is, if something pops in my head I want to add to my CV, I always immediately write it down on a sticky note or a piece of paper, just because I know I'll forget it. And having a kind of a source of maybe just sticky notes saying, oh, add this to your CV, that will, trigger your brain at one point to say, oh, I better actually go update it. Because it is important. You'll be amazed at the things you can't remember, a couple months later, that you want to know the details of, and then you forget. For example, if you did go give a presentation at a conference, a couple months later, maybe you forget the date of the conference, or you forget, your poster number, perhaps. Those kind of things might be important. But I think in general, the most important thing you can do with CVs is just look at other people's. I guarantee you that any academic professional that you've interacted with, they have a CV. Most of them will have websites, and almost everyone puts their CV on their website. So you can feel free to just go to your, if you have an advisor, or if you have a professor that you've taken a class with in college, and you're curious to know more about them, I guarantee you they have a CV, and you can read theirs and kind of get a sense for what other CVs look like. Because again, mine is just one example, and there's no right or wrong way to do this. So looking at more examples will help you learn about what you want to put on your CV. The last thing I want to say is something that's relatively new to me. I only learned about this maybe 2 months ago, and it's kind of the opposite of a CV. It's called a failure CV. And I wrote up a little bit for myself here. It's called a failure CV. And the idea is that a CV is supposed to be this glowing document of all your accomplishments and all the things that you've done and you've earned, and how wonderful of a researcher you are. And so when you do go look at it, say your favorite professor's CV, like, you'll read it and you'll be like, wow, they won all these grants, and they did all this outreach, and they got into these great schools, like all these wonderful things. And it'll seem like everything just always fell in their favor and everything worked out for them. But that's very often not the case. Even people who are very successful in the sciences, struggle tremendously through their career, through high school and undergrad and graduate, and they apply for things and they don't get them, and fellowships don't come their way, and grant money doesn't come their way. And maybe they applied for telescope time and they didn't get it this semester or in this year. And so none of that information ever makes it onto a CV, because it's not considered like an accomplishment. Oh, I didn't get this fellowship, so I'm not going to put it on my CV. If I did get the fellowship, I would put it on my CV. But so there's been this new kind of trend of creating what they call a failure CV. And it's supposed to be the opposite of a CV. It's supposed to highlight all the things that you didn't get, and all the schools you didn't get into, and all the grant money that you didn't win. And the idea is to kind of make our field, I would say our field astronomy, but this works for all fields, to make our field a bit more transparent to kind of like the roadblocks that even successful people go through. It's not supposed to be embarrassing. It's supposed to be in some ways humbling, in some ways very transparent. And the idea is, just share the things that didn't go your way. Because then if you do become a professor one day, if you choose to pursue that route, and then you're mentoring, a high school student, and they say, oh, I applied to these things and I didn't get them. And you say, well, look at all the things I didn't get, and here I am. And so it's supposed to be partially inspirational, and partially humbling. And so I think it's a wonderful thing. So I took the time to put together my own failure CV. I have a list of schools that I did not get into. I have a list of jobs that I was rejected from. I have a list of fellowships and grants that I didn't get. And so again, the idea is to just show that, while I'm a grad student and I've gotten into grad school and I'm loving it, I'm having a great time and I'm working hard. But it wasn't necessarily easy or a straight path or anything like that. And so, I think generally the fields of science, I think, would be a better place if more people created these failure CVs as a way of showcasing that it's not necessarily an easy path, and anyone who it looks like they had it easy, I guarantee you they had stumbling blocks too. And if they overcame their stumbling blocks, you can overcome your stumbling blocks. So yeah, I wish that people had been doing this 30 years ago, so that we'd have these failure CVs that were, really long of people who are very successful, and you can just see how even success had its rough spots. But unfortunately, this is a new phenomenon. So I guess all that to say is that, if in 20 years we want people to have these kind of expansive failure CVs so that we can point to and say, look how it wasn't easy, and look how you can do it too. That means we need to start today, and that means that's our generation of people who are currently in high school, currently in undergrad and grad school, starting to create these and share them openly as a way of making all of science just kind of more accessible and transparent, and just kind of a better community in general. So I do encourage you to kind of keep track of the things that you don't get, because then when you do get things and you look back and you say, oh wow, look how far I've come. So anyway, that's about my time. It's been about 20 minutes. So I will turn it back to Faye, but if you ever have any more questions about CVs, feel free to shoot me an email. I flashed my email up on the share screen when I was going through the CV, excuse me. So yeah, feel free to give me an email anytime. So, all right, I'll turn it back to Faye.
Thank you so much,
Thanks.
Jack. Failure CVs definitely sounds like fun, and I wish I could have seen some of those during my undergrad to be more encouraging to me. Yeah, thanks a lot, Jack. Next speaker is actually myself, and the topic is creating a professional website. Let's see, let me share my screen. All right. So the next topic is how to create your own research website. Before we talk about the details of how to build your own website, let me first give you a few reasons of why you would like to have a professional website in the first place. Well, a good professional website goes a long way in your scientific career, can help you find potential collaborations or even help you land a real job. And a good website is usually a very easy way for your fellow researchers or future employees to learn more about you and your research. The website can be much more interactive than your CV. You can include videos, plots, or background stories about your ongoing research. And you can be more colloquial in your website compared to a published journal article. And this usually helps to appeal to a broader audience. And you can also use your website to do outreach and collaboration. People may get into contact with you if they're interested in your work. So what are some of the key things you should consider putting in your website? Well, first of all, a clear recent picture of yourself. So if you ever go to a conference and people will recognize you. You should also put some basic contact information. Definitely your email address, your mailing address, and maybe your office location if you want to meet people in person. Your CV, as Jack mentioned, it's very important. You should put it somewhere obvious so that people can take a look at your CV on your website. You can also write a short autobiography, where you grew up, what led you to research in astronomy or in science in general. And you can also put some of your hobbies outside research there. For example, if you play the violin or you're a rock climber, this may help you find some connections within the community. Another thing you should definitely put is a list of publications, including books, conference proceeding, refereed articles. You can also try to group your research into different areas. That way, you can discuss the current status of that particular subfield, what is known, what remains to be explored, and how your research addresses those questions. And you can upload recordings of your talk to your website. Effective communication in science is really valued, and you want to showcase that to whoever is visiting your website. And you have some professional research profile, for example, Google Scholar or ResearchGate. You can also link them on your website. Those websites typically host a more up-to-date list of your publications. Let's see. All right, here are some other things you should consider putting in your website too. For example, your expertise. Maybe you're particularly good at coding, or you know how to operate certain laboratory apparatus. Yeah, link all your publications, be journal, books, other things. Your current research and overall research goal. Where do you see yourself headed in the next 5 to 10 years? Your honors and achievements, maybe scholarships you have gotten or other funding sources. Professional affiliation, definitely put your university or whichever professor you're working with on your website. Teaching, well, if you have done some teaching as an undergrad, it's definitely worthwhile putting it on your website. So a lot of this overlap with what Jack just talked about on your CV. But on your website, you can afford to go into more depth about all the different experiences you have and putting them in different sub-pages so people interested in a particular area can navigate there and read more about your experience. Another thing I should mention is if you keep a scientific log, for example, you write about science or do science outreach, you should definitely link it on your website. Yeah, if you have social media that also does science outreach, feel free to link them on your website. All right, so how do you actually build a website? In general, there are two ways. The first option is to use commercial websites, such as Wix and Squarespace.com. They're usually very easy to use, and they also provide you with a domain and actually host your website for you if you pay them a monthly subscription. It's usually a few dollars per month. The other option is to write your own HTML file. This is usually a lot more flexible. It's actually easier than you think if you can start with a very good template. Here, this html5up.net is a good resource if you're looking for some template. All you gotta do is to download that template and replace text and figures in those templates and maybe rearranging them a bit. The downside is, of course, you have to find a domain and hosting for yourself. But usually a school can do it. You can host your web page on the department website. You can ask people in your department whether this is feasible. And I'll bet they usually say yes. Now, what to do now that you have a website of your own? Well, first thing you should do is to link your website in your email signatures. Here I put example of my signature, and the URL to my website is attached to the very end. This way, whenever I send email to someone I don't know or someone who know me very well, they can look me up on my website. You should also link your website on your CV or other social media if you do use social media for science outreach. Also, you should definitely update your website periodically. That way people would know you're still active in research, and yeah, that's pretty much about it. So next, let me show you a few examples. Well, a shameless plug for myself. This is my personal website, and this is the corresponding HTML file for it, which I downloaded from the HTML template website I just showed in the presentation. So a big clear picture of yourself, hopefully recent picture, and you can see the picture is here in the HTML file here, image /pic1.jpg. You can replace that with your own. And usually a good HTML template is well commented, so you know which different section correspond to. For example, here, header correspond to this section of my website. And you can change these to your own name or your own positions. And you can have a few different navigation pages. For example, here I have home, research, publications, community service, and biography. And you can click on them, and the website will be navigated to the appropriate places. As I mentioned earlier, you want to include your CV somewhere that's easy to find. For example, if you click this button, you will download a copy of my CV. Yeah, let's go back. A few other things for research. What I did is group my publication into subtopics where there's a clear theme for each topic. And you can write about these topics in a very colloquial manner so that general audience can understand what your research is about. Yeah, a list of publications. For example, here I put some of the papers I wrote and some summary statistics. And you can also link to professional website. For example, here is NASA ADS. So my name is pretty common in China, so there's a lot of overlap. So this ADS link actually generates a unique pointer to your research profile. So people will know exactly what you published and do not have to confuse you with someone else with a similar name. If you have done some community service or outreach, you should also put them here. Yeah, a brief bio, where you grew up, how you ended up working as a journalist. That may be an interesting story for many people to hear. All right, so this is using HTML file. Let me also show you how to use Wix to create your own website. Let's probably start here. So within Wix, you can also search for different templates. For example, here the keyword I use is researcher, and you can see various templates popped up. You can just pick one that you like. Maybe let's start with this one. I already preloaded it. So it's very similar to Microsoft Word. You can put pictures, put links, put texts here. And you can drag things around, for example, the picture here. And you can change picture by uploading your own. Just drag and put it here, and you'll be able to link those. And you can change the title to your own name, maybe. Just try my own name, positions, what you're interested in, maybe exoplanets. Another thing I should show is there are different navigation pages. So this is a quick way for visitors to see different sections of the website. For example, publication. Here they already included a list. You can just update the list. Maybe 2020 and whatever journal you wrote. Yeah, all these should be pretty straightforward. And the assignment for next week is actually to create your own website and your own CV, and feel free to post them on piazza.com. Our mentors will do our best at reviewing your personal website and hopefully provide you with some constructive feedback. It doesn't have to be super complete. If you just have a template and fill in a few of your personal information, that's good enough. And you can start building on that later. We have more experience. Right, I think that's all for the research apps website. And the next topic today is the James Webb Space Telescope. And the presenter is myself again. Find the correct presentation. All right, So the reading assignment from last week is about the ongoing James Webb Space Telescope, or JWST in acronym, and how you will transform our understanding of planet formation and the universe in general. I know the paper is a bit technical and you may be lost. Let me just give you a big picture view of what is going on. I think it's fair to say that the study of exoplanet revolves around the question, are we alone in the universe? For a very long time in human history, we have approached this question in a religious or philosophical framework. However, modern astronomy has enabled us to discuss this question more scientifically. Specifically, if you use the Drake equation, which reduces this rather large or metaphysical question of are we alone into a number of smaller, testable questions. Namely, the number of communicable civilizations in our galaxy should be roughly the product of the average star formation rate in our galaxy, times the fraction of those stars hosting planetary systems, times the fraction of those planets ending up in the habitable zone, times the fraction of those planets supporting life, times the fraction of life becoming intelligent, and times the fraction of those civilizations these intelligent life develop actually has a desire or the capability to communicate. And finally, times the average length of those civilizations lasting over time. So the advancement in modern astronomy has showed us pretty clearly what the first two terms are. We now know the average star formation in our galaxy is about a few solar mass per year. And the Kepler mission, which we'll talk about shortly, has shown us almost every sun-like star has an order of unity probability of hosting a planetary system. And then in the next few decades, upcoming missions, including JWST, will begin to show us the next two terms, which are the number of planets being habitable, as well as the fraction of those habitable worlds supporting life. So far, there are more than 4,000 confirmed exoplanets. If we plot them on this orbital period versus mass diagram, we can see that different detection methods showing different color here correspond to different types of planets. And the radial velocity and the transit methods are by far most successful if you count the number of detections. And these are showing the red and the green boxes. The transit method, I think Priya briefly touched on this, basically looks for periodic dimmings of the host star caused by a transient planet. If we can monitor thousands or even millions of stars at the same time, some of that star will have the planets aligned with Earth, line of sight. So these planets will periodically block this host star and cause a dimming of the star's brightness. And from the period, you can tell the orbital period of the planet, and from the dimming, you can tell the rough size of the planet. And this is the transit method. And another method we can detect exoplanets using radial velocity. According to Newton's third law, every force or every reaction has its own reaction. So when the planet is being pulled by the host star is also being gravitationally perturbed by the planet itself. But we know the stars is generally much heavier than the planet. The motion of the star is usually on a much smaller scale and with a very small velocity. If the entire solar system only has planet Earth, then our sun will move at about 10 centimeters per second on a yearly orbit. And according to the Doppler effect, when the star is moving towards us, its light will be blue shifted, and when it's moving away from us, its light will be red shifted. This phenomenon is behind the reason why we hear the pitch difference of an incoming train versus an outgoing train. And if we measure a distant star's spectrum and observe this periodic redshift and blue shift, we can potentially tell the existence of the planet as well as mass. And this is the radial velocity method. Actually, the first confirmed exoplanet around the main sequence star, 55 Peg B, was detected using the radial velocity method. And Swiss astronomers Mayor and Quillos was awarded the 2019 Nobel Prize for this discovery. Another thing I want to mention before we talk about JWST is planet occurrence rate. Just now I mentioned that we know pretty clearly what is the typical fraction of stars hosting a planetary system. And this is thanks to the NASA Kepler mission. Kepler was launched back in 2009, and it was a wide field of view transit mission. It monitored almost 500,000 stars for about 10 years. And with that, it discovered more than 2,600 exoplanets. And with such a large number of discovery, we can actually begin to do some occurrence rate study. And two of the most striking results that came from Kepler is that, first of all, our galaxy is filled with the so-called super-Earths or mini-Neptunes. The super-Earths are rocky planets at about peak at about 1.5 Earth radius, and the mini-Neptunes are miniature version of our own Neptune with a thick layer of hydrogen and helium, and the radius typically is slightly above 2 Earth radius. And if you tally them together, you'll find that at least 50% of Sun-like stars host one such planet. And the next question is, how many of these planets are in the habitable zone? Well, currently our definition of how the habitable zone is still quite limited. As long as the planet has a rocky surface and the surface temperature is in the correct range to maintain liquid water, we call a planet habitable zone, a habitable planet. Everybody talks about life as source of life, and we know most of the biomedical reactions actually happen with water as a universal solvent. We know this current definition of habitable zone is quite limited, as it is mostly based on the life as we know it. But we have to start somewhere. Rather than looking for life or extraterrestrial life that we have no idea about, it's probably easier if you just look for Earth-like life in the first place. For Sun-like stars, the habitable zone is close to 1 AU, where Earth is. But for smaller stars, since those stars give out a smaller amount of energy, the habitable zone are usually closer to the host star. And these are the planets we hope to study with JWST. So the final mission I want to mention before JWST is TESS. So Kepler's mission discovered a lot of planets, but one limitation of Kepler is that only covered about 0.5% of the night sky, showing the brown area here. The TESS mission adopted an entirely different strategy. It observed almost the entire sky, as the talk by Sam last week I've shown you. This strategy allows TESS to discover some of the closest planets around Earth, and these are the most amenable for follow-up study using JWST. This is perhaps best shown on the diagram on the left. The planet discovered by TESS, showing orange, is typically 1 or even 2 orders magnitude closer to the planet discovered by Kepler, showing blue. And these nearby systems are very amenable to the detailed characterization with JWST. So finally, onto JWST. JWST has an aperture of 6.5 meters, which allows it to collect 6 times more photons compared to the Hubble telescope. Its primary mirror is made of beryllium, which has really low thermal expansion, and the surface is coated in gold, which has very high reflectance in the infrared. And there are 18 mirror segments for JWST, and these segments have to be aligned so perfectly that aligning them took almost 6 months. And this is a delay you heard before the launch of JWST and the imminent first science data release. That's going to come out tomorrow, so stay tuned. So by observing in the near infrared, JWST has a lot to offer. So the JWST wavelength coverage is between 0.6 micron to 28 micron. And on the left is the transmission curve of Earth's atmosphere across almost the entire EM spectrum. Notice that the molecules that are potentially biosignatures, for example, water, in our atmosphere, are strongly absorbing in the near infrared. As a result, we have to go to space if we want to study these molecules on exoplanets. And JWST is put at the so-called second Lagrangian point, L2, which is slightly outside Earth's orbit. At this point, Earth's gravity, Sun's gravity, as well as the centripetal force roughly cancel each other out. So JWST can stay here for a relatively long time without needing to fire its onboard small rocket to correct its orbit. Also, as L2, JWST is relatively free from the scattered light from both Earth and Moon. By operating in the near infrared, JWST will have a better chance of detecting the light from the exoplanet themselves. This is generally because the light emitted by a body is related to its surface temperature. The exoplanets, for example Earth and Jupiter analogs, are much cooler than our Sun, hence they emit their peak emission in the infrared. So by operating in the infrared, JWST can achieve a much more favorable contrast between the exoplanet and its host star. Also, another design from JWST is sun shield. The sun shield is actually made of 5 thin films, and between each film, the sunlight that has leaked from the previous layer can bounce around, actually escape at the edge of the layer, and this helps to reduce the temperature of JWST tremendously. I think on the first film, the expected temperature is about 86 degrees Celsius, whereas by the time we reach the last film, the temperature would drop to minus 230 Celsius. And this greatly reduces the thermal noise we observe in the near infrared. Alright, so how does JWST tell us about exoplanets? Well, there are a few ways we can characterize exoplanets with JWST. And the first method is transmission spectroscopy. Basically, when the starlight goes through the planetary atmosphere, some of that light will be absorbed or scattered by the molecules present in the atmosphere. And by studying these scattering absorption, we can deduce the atmospheric composition as well as thermal structure of the atmosphere. And perhaps most exciting will be the detection of water on small planets. And on the right is a simulated detection of water at about 1.4 micron band. Another way we can study exoplanet with JWST is to use phase curves. 400 years ago, Galileo observed Venus's phase curve, and this provided strong support for heliocentrism. So what is a phase curve? Well, basically a planet that is revolving around its host star will be strong illuminating in its day side, where the sunlight is directly shining on the planet, and its night side will be much cooler and there's no reflected light from this night side. So as a function of orbital phase, we will see a different balance between the day side and night side, and the planet's brightness of apparent brightness will change as a function of our orbital phase. So JWST will be able to measure the phase curve for some of the close-in exoplanets. And we can use the phase curve to tell whether the planet hosts the atmosphere. So the panel on the bottom, the 2 panels on the bottom are simulated JWST observation. On the left, we can see that if a planet has a thick atmosphere, the atmosphere will act as a thermal blanket and transport heat from the day side to the night side. So overall, the phase curve will have smaller amplitude and shifted to the afternoon side on the planet. This is similar to why 3 p.m. is hottest on Earth. On contrary, if the planet is a bare rocky core, then all the heat will be radiated locally, and the phase curve will be just a sine curve that is centered at phase of 0.5 which correspond to the planet directly behind the star. If we can repeat this phase curve analysis at different wavelengths, which is shown on the right, we can potentially tell the dominant mineralogy on those planets. For example, if the mineralogy is Earth-like, in other words, containing a lot of granitoids, then we should expect to see a lot of silicon to oxygen bond absorbing in the 8 to 10 micron range. And these are some of the observations we hope to do with JWST. Another final effect I want to mention before we end is the so-called vegetation edge. A few decades ago, Carl Sagan proposed a challenge to the scientific community. And the challenge is that, say if we use Voyager, which by the time has already reached the orbit of Saturn, if we use Voyager and turn it back to look at Earth, from the point of view on the orbit of Saturn, Earth will appear nothing but a pale blue dot. Pretend that we didn't know life existed on Earth. What kind of observation could establish the existence of life on Earth? Maybe the similar method can be used on other exoplanets with JWST or any upcoming missions. And what Carl Sagan found was one of the more compelling evidence for life is the so-called vegetation edge. And this is using a key peculiarity of chlorophyll of plants. Chlorophyll can absorb visible light and turn them into chemical energy. But in order for the plant to stay cool themselves, the plants also give out a lot of light in the near infrared. As such, if you plot the reflectance of plants as a function of wavelength, there's a sharp increase just beyond the visible range at about 700 nanometers. And this is the so-called red edge. And this effect is different from many other known geological or atmospheric phenomena, and is considered one of the more reliable biosignatures. All right, I think that's all I wanted to cover for JWST and the various exoplanet observation it may provide with us. Please stay tuned for the actual science result that will come out tomorrow, and we are already excited to see what JWST first result will show. All right, with that, let's move on to the final topic today. Just mental profile by Sam. Sam, are you there?
Yep, I am here.
Go ahead.
All right, so I don't think this will be a very long section because I don't think I have that much to say. But basically how, I guess the point of these mental profiles is to tell you how we got to where we are. So I am currently a fourth-year graduate student at Princeton. I work with Josh Wayne on exoplanets, and I work a lot of test data, as I mentioned to you last week, and that's really exciting. As you've also heard from Faye today, that test is really, because it's an all-sky survey, it's really enabling us to do things that weren't possible with previous missions like Kepler, and in part also because it informs target selection for future missions or ongoing missions like James Webb, as well as future ones like Ariel. And yeah, so I am really lucky to have been able to come to a school like Princeton and do research in astronomy, and I think it's really, really exciting. So yeah, so I was born in Singapore, and I did all my early years of life there through high school in Singapore, and I really didn't know that it was possible to be an astronomer at all, right? Like there aren't really any astronomers in Singapore, at least not at that time, and so I think it's I never imagined being able to do this for a living. It wasn't until I managed to go to college. I did my undergrad at Caltech in California, and I was very lucky to get to go there again, because that was an amazing place with tons of interesting research in all kinds of fields going on. And yeah, and so one of the summers when I was an undergrad there, I just emailed a whole bunch of professors. I actually kind of wanted to do like some more physics-oriented research, but nobody in that nobody that email got back to me except for one professor who was working on exoplanet atmospheres, and yeah, and so I decided to work with their group during that summer doing undergrad research, and I just found it amazing because I think it's such an interesting exoplanets in particular is such an interesting area of research in an already interesting field, which is astronomy, and it really lets us get at some really fundamental questions, including like Faye mentioned earlier, are we alone in the universe? And it was because I had such a good experience working with people as an undergrad with some really, really good mentors that I decided to apply to grad school in the same field, and that's where I am now. And yeah, so I think what's most important to take away is try some of these things out. I know it's not always easy to find these opportunities, but you might be surprised at what you find interesting and what you find yourself to be good at doing. Even if it's not necessarily the first thing that you wanted to do, it might still be interesting. So you should always just give it a shot, even if it's not your first choice.
Yeah, definitely.
Yeah, I don't think I really have that much else to say because I'm still figuring out my path in this field. So yeah, I don't know. There's no real way to know what your path will be. So the only way is to try many different things and figure out what you enjoy.
Yeah, definitely. Yeah, I would also suggest feel free to reach out to your local faculties for research positions. I think that's the best way to get things started.
Yeah, and if you ever need help with things, I think people in our field especially are always very helpful. I've never had a problem emailing somebody about with a question I had, and they're always happy to answer. So I think that's really one of the nice things about our field.
Right. Thank you so much, Sam. All right. Thank you, everyone. Let me remind everyone to check out the assignments and additional resources for this week on our course website. And we also strongly encourage you to take a step at creating a CV and website. Please post them on piazza.com, and our mentors will take a look, hopefully provide you with some good feedback. And next week, we'll meet here again on Monday, and we will talk about grad school application as well as planetary science, particularly focusing on the Pluto Charon binary. Take care, everyone. See you next week.